7D, Open Data and Data Publishing Governance in the Big Data Age. My name is Gao Xingming from China Internet Society, in charge of the Vice Chairman. This workshop is hosted by Consultative Committee on United Nations Information Technology under the China Association for Science and Technology. You know, everyone, nowadays the internet has started into the area of the big data. What is meaning the big data? It's different definitions. But all know, since 1990s, the data volume has increased tremendously, and also pay attention a lot of application of the big data technology. Is newly developed very fast. Nowadays, almost every day create 2.5 exabytes. So big data area always coming. But big data is not meaning of the size of data, but also their meaning of the type of data. They are not single text data, but also all the unstructured data, including video. And also, it's data, big data, meaning the speed of the change of the data. Data in and data out. So big data is very important technology and application in nowadays, particularly in the internet cycles. Open data. This concept is not new, but the formalized definition of the open data is a new one. Because the open data is follow the open trends, open source, open hardware, open data. In recent years, a lot of governments launched the initiative Open Data Government. It is started from 2008. A lot of governments, including in developed country and the developing country, already launched a lot of initiative of the open data of government, so-called the data.gov. But in the big data era and the open data movement still suffer some problem, particularly the policy side, governance side. So this workshop, we will focus on this side, not big data technology, either open data technology, but we focus on the application aspect, particularly how to design the policy, promote open data applications in big data area. Our workshop, we invite a lot of distinguished panelists. Let me first of all introduce them to everyone. On my left is Professor Zhou Qiang. He is a fellow researcher in the China Academy of Science Institute of Remote Sensors and the Digital Earth. He will make some presentation concerning of the use of the open data and the big data technology in the remote sensors data areas. Next of the Mr. Zhou Qiang is our distinguished panelist, Ms. Anna Navy. She's come from Portugal. She's a very he's a very famous specialist in the policy making in the internet governments. We have a lot of cooperation with her, and he joined us almost every workshop in the IGF process. Thank you. Then on my right side is Professor Liu Chuang. Yeah, she's also come from China Academy of Science. He's a fellow researcher in the Institute Institute of the Geography Science and Natural Resources. Mr. Liu Chuang is also very active participant in all the international conference on cold data forum. It's a very important organization in area of the open data and promote the big data applications. Then, on my right hand is coming the Professor Severtina, excuse me, it's my difficult to pronounce the Russian names. She's come from Russia, National Research University, Higher School of Economics. She's also very fair research in big data and open data areas. She will tell us about the application of the big data in education and the business sector in Russia. Now, I want to suggest our workshop will divide two parts. All the speakers, the panelists, makes their presentations. Then after all the presentation finished, then open the discussion and the comments for audience and remote participants. If you agree with me, then I would like to invite Ms. Anna to make first presentation. Now, you have a floor. You can start it.
Thank you very much, and good afternoon. Well, I see my PowerPoint a bit far, so I think I'm going to see my notes. So, well, I have a PowerPoint. Like that? Okay? Okay, thank you. So it's a bit, well, I was saying that I'm a bit far from the screen So it's a bit difficult to read what is there, so I'm going to read my notes because I don't know by heart my presentation. So sorry about that. The vision of my presentation is the following. So the vision is scientific infrastructure that supports seamless access, use, reuse, and trust of data. In a sense, the physical and technical infrastructure becomes invisible, and the data themselves become the infrastructure. So this is key. A valuable asset on which science, technology, the economy, and society can advance. So this is, I'm quoting the European Commission in this publication, Europe is Riding the Wave. So I will tackle some issues about this open data and data publishing governance in big data age issue. So I'm going to talk about what means big data age. What does it imply? The change of the paradigm. So science will be organized differently. What does that mean? The benefits of scientific open data, the cross-cutting obstacles, what could be a new model with open data in Europe. And to wrap up, I will present the case of Portugal and what is going on there on open access on data. So here you have what we have now in life, what it means big data, because this is the reality. So now big data, you know that it refers to large amounts of data produced very quickly by a high number of diverse sources. Data can either be created by people or generated by machines. Whether it is geographical information, statistics, weather data, research data, transport data, energy consumption data, or health data, the need to make sense of big data is leading to innovations in technology, development of new tools and new skills. So you can see here that now we live in a big data age, meaning the digitization of all media, the migration of social and economic activities to the internet, the increasing deployment and interconnection of sensors through mobile and fixed networks, so Internet of Things, widespread availability of infrastructure, convergence of devices, functionality and capacity of devices and networks combined with mobility, and participative web. So it's huge, what I said. So this new big data age is really means a lot, means a big difference. So here what I want to present is really what it means, this big data age regarding the data value chain and life cycle. So you see here generation of data, the collection of data, the storage, the processing, the distribution and analytics of data. So it means that innovation will be further driven by open access to data, which also enables consumers to be better informed. It's not only for researchers and companies. In addition, substantial social benefits are also expected from collection and analysis of data. For example, when addressing aging society and natural disasters. However, the use of data and analytics come with policy challenges, including, but not limited to, the promotion of trust among individuals and consumers, and the development of data analytic skills that, if not supplied, could lead to missed opportunities. Okay, it's this one. So now I'm going to talk about the change of the paradigm. So with all these changes, we are facing a new paradigm. Because exponential growth of open data affect the whole research cycle and its stakeholders. For example, globalization and growth of the scientific community implies ongoing transition to new ways to perform research, researchers' collaboration, the increase of knowledge circulation, which is shared much more easily. Therefore, science will be organized differently. Successful use of digital technologies demands interoperable data infrastructure. Mobile connection and other network and digital technologies permit great benefits from networking and scale. But data-driven research and innovation technology must be efficient to be effective. So, towards a more open interoperability and shared scientific information, the importance of open data. What does open data mean? So, open data. Well, it means data that can be freely used, shared, and built on by anyone, anywhere, for any purpose. They are digital, they are online, free of charge, and free of most copyright and licensing restrictions. It will change the way research is undertaken and communicated globally. So this is something that is not happening. So what I said, it doesn't exist. But open data means what I said. The access to research data will radically transform research disciplines, but we have to find a common understanding, not only of what the publication is, but what data is as well. So, in this big data age, we have to encouraging open data and data publishing governance across society, which implies access to and the reuse of data to maximize economic and social value of the data that we have. The public sector become one source of data and an important national data stock, which can be better exploited. So this already exists with the e-government policies. To promote access to private sector data with increasing number of private and public initiatives. It promotes cross-disciplinary players, institutions, infrastructures, projects, archives, and other repositories. And the need of protecting the privacy, but not forget the utility of big data to the society in the future. So protect, but not in a bad way. So now about the benefits. Well, maybe you cannot read anything. So, but the point here is that the benefits for citizens, funders, and policymakers, researchers, enterprise, and industry. So the benefits for citizens are mainly appreciate the results of, and benefits arising from research and feel more confident in how their in how their money is spent, find their own answers to important questions based on real evidence, part of knowledge and experience to others, and make a contribution to the knowledge society beyond their immediate circle and lifespans. For funders and policymakers, what are the benefits? So they will make evidence-based decisions, eliminate unnecessary duplication of work, get greater return of investment. Benefits for the researchers: have all data and tools easily available, increasing the productivity, cross-disciplinary boundaries, gaining new insights and producing new solutions, and stand on the shoulders of giants. That is a phrase that I like. Enterprise and industry. They use the best available information from the research and the development. They will create new knowledge, markets, and job opportunities, provide a strong industrial and economic base for European prosperity. Of course, I'm talking about Europe because I'm European and I'm really working on Europe perspective and vision, but this is really a worldwide perspective. And it will increase opportunities for mobility and knowledge exchange. And what I was saying about Europe is really true, because we are trying to follow best practices all around the world. We are trying to work with Asia, we are trying to work with North America. We are trying to work with all countries to see which best practices they have in open data. And I can see that we are more or less all on the same page. So the cross-cutting obstacles. So it's the other part of the slide that you have there. Lack of long-term investment in critical components such as persistent identification, lack of preparation, lack of willingness to cooperate across disciplines, funders, lack of published data, lack of trust, not enough data experts, the infrastructure is not used, too complex to work, lack of coherent data description, allowing reuse of data. So this is a problem not only of the publishers of data, but of the researchers, that they don't want to open their data. So, which are the barriers to change data publishing governance? So, the main obstacle here is to change data publishing governance. The current reality is inaccessibility of data. Scientific results are shared through literature without access to data. So you have access to scientific publications, but you don't have access to the data used. So no uniform mechanisms to publish data. Some disciplines, communities are quite advanced in making data available, but it is exactly the opposite on others. Not for all data, not for all disciplines, I don't know. So we are discussing this. It raises several issues about privacy, security, and intellectual property rights. The barriers to long-term preservation, so another obstacle. And finally, the last obstacle that I have here is the different legal and regulatory frameworks within different countries and across continents. What's happening? Nothing is there. Ah, okay. Everything is there now. Ah, more. No, too much. Oh my God. Okay, I got it. Okay. So again, it's a pity that you cannot really see what is there. So it's a new thing that it's coming from the European Commission, and that I thought it could be very interesting for this workshop. European Commission is proposing Europe Science to 2.0, science in transition areas and issues. So what we have there is a possibility for a model if we use and if we have access to the data. So if we have a new data policy, and so we will have a different data publishing governance in Europe in big data age. So what we have there in that blue part is infrastructure. So we need to invest a lot on infrastructure for big data and data flows, of course. So we need the citizen engagement, citizen science and crowdsourcing, open access to research results and processes, evidence-based policy making, global systems science. So the point here is accompany a change in culture. So now to finalize my presentation. Okay. I will say something what is going on in Portugal, what is happening. So it was not possible to launch yet a policy on open access, on open data access, but an incentive to the openness of data and sharing of research data from scientific publications from publicly funded research. We recently adopted an open access to publications, so we have a new policy. So the core of the Portuguese policy on open access to publications arising from FCT, so it's the Foundation for Science and Technology, so the funded research. All publications of research output subject to peer review or another form of scientific review should be deposited in one of the open access repositories hosted within RECAP. I will tell you later on what RECAP is, as soon as possible, preferably immediately on acceptance for publication. So this is really good for the open access to publications, but the open access to data, it was not possible. The researchers didn't allow us. So the policy on management and sharing of data and other results arising from the National Research Council Foundation for Science and Technology that funds research is to encourage now research to share primary data and other data within the scientific community by placing the data in open access database within the shortened time possible. And finally, example of the open access repository where we could deposit data. So we operate this open access through the RCTS, the National Research and Education Network, which has 10 gigabits, and it is scalable. We have a Beyond Knowledge library online, which is possible through deals with the publishers. And we have a RECAP, that is the Open Access Scientific Repository of Portugal, which presently it serves all the universities and all the researchers in Portugal. And we have a cooperation with Brazil on this area, which we plan to extend to all countries that speak Portuguese. These are my main lines where we are on open data access in this big data age. So I just wanted to give you some lines of the difficulty of the long way that we still have to have open data access. And I wanted to give you what a new model could be if this data would be open. Thank you.
Thank you, Ms. Levy, for your interesting presentation. Particularly, you very clearly define the big data and the open data concept very clearly. And also you give us some example as Europe Science 2.0. Its framework is based on the open data concept. And also he shared with us the experience, practice experience from Portugal, particularly the open access of a library and other scientific data. Thank you very much, Ms. Anna, for your contribution. Now, I want to invite Ms. Zhou Qiang make a presentation. I think Ms. Zhou Qiang is, I think maybe he gave us some idea and advice on the big data application in science research areas, particularly in the remote science data, how to proceeding and use big data technology. Now, Mr. Zhou Qiang, you have floor, please.
Thanks, Mr. Gao. Good afternoon, ladies and gentlemen. Glad to meet you here. Today I'm going to talk about the research big data, some issues about data in cyberspace, data science, and research big data challenges and opportunity, especially on data sharing. So as we know, cyberspace is filled with data as the space completely filled with matter. It's an artificial field since it was born, and there have been various data-driven activities in cyberspace every moment. So you may notice from right graph, there had been a steep increase on the data volume in recent years. In 2011, the amount of data being created and replicated worldwide is about 1.8 zettabytes, and the global amounts of data will be expected to reach 40 zettabytes in 2020. So it's a very, very huge increase. Sorry. Oops. So the computers, switch, routers, fiber optic cables, wireless, satellites, even satellites, all these components are connected in the network. And all the researchers, as commercial users, individuals and decision makers are important contributors and beneficiaries in the big data age. So not only emerging networking technology, but also open data, all of us are contributors and beneficiaries. So based on my research background, taking Earth observation as an example, as you may know, satellites provides observation of planet, which is essential to enable wide public service, accurate weather forecast, and warnings. Also, satellite navigation, which is familiar to each of us, and benefit scientific research. That's a point I'm going to talk. So more and more satellites with diverse features will be launched. So you may know some open data service provided by the United States, also Chinese satellite. There are also some special satellite designed and launched for scientific experimental. Also, Skybox is very, very fantastic project. It will launch 48 small satellites to acquire tons of data, which will be used of different fields. So, satellite data not only support routine public service, but also benefit scientific research. So in simple way, data cycle includes data acquisition and transmission, data processing, and data application. All these are important stages of open data. Here you see is the in-orbit set of Chinese meteorology satellites. It's called Fenyun satellites. There are many, many satellites from different countries. These satellites circulate the Earth continuously and accumulate massive data with wide spatial and temporal distribution. The data from these satellites will be important input for climate change research, also weather forecast, and so on. And you may see this is a roadmap of Fenyun satellite to 2020. It means we are got many, many data from different satellites, from different sources, from different countries. So all this data, I mean the MODIS data, Fenyun satellite data, they provide online open data service. The researcher and the public can download and use this data freely. This is the example captured by Fenyun 3A. You may see, sorry. This is an image of Fenyun satellite. So you can see the river, the width variation of the river. Actually, in 2013, it experienced a severe flooding in the northeast China. This is the image after the disaster. You can see the coverage and of the flooding. But if you see the other image before the flooding, so it's very different. So this is only the data on resolution of 250 meters. If we get more data of high resolution, we get much more information and much more useful knowledge for decision making and also public. So generally speaking, there will be more open data with high resolution and higher precision in cyberspace. It has become indispensable strategic resource to support scientific research and various application service. So in big data age, data science is also a popular topic. So what we now do for our scientists is we convert data to knowledge or to information. It requires different theory and technique from many fields, like what we are familiar is data warehouse and high performance computing. So data science is emerging to meet all challenges of processing very large data set, and most of unstructured or semi-structured big data. So why I'm talking about the big data, especially scientific data processing? Because the computing capacity, I mean not technology, but also the open data we get from the website can support this kind of research. You can see many publications and journalists or report provided by the government or journal and the research like CoData. It has a data science journal and the PCAST report, and also Nature and Science already issued a special issue about big data, and they are also very famous forced paradigm. And for United Nations, in 2012, United Nations released a larger data government white paper, and also Gartner proposed 4V definition of big data. So as we can see, data analysis has become the fourth foundation for the scientific finding besides theory, experiment, and computation. Oops. Oh, yes. So as Anna talked, there is a definition for big data, except volume, velocity, variety, and value. We also have some special concepts on the scientific big data, because it's not only the description of the large data set or data volume, and it's not also the processed with the existing technology method or series, and also the scientific big data grows rapidly, but it's not staged, just as like social computing or commercial computing, because I think there is still an initial stage, very beginning. What causes this? Because of some very special characteristic. As we know, the scientific research, it requires different theory and practice of data, unlike the ordinary, which we are familiar with the high dimension, and it has to reflect complex process and the relationship of natural and social phenomena. So it has very special, very high requirements on the data representation. It's quite complex. Taking the example, if we want to do something about spatial and temporal analysis of socio-economic phenomena, we have used a lot of data. This data can be natural and geographic data with different spatial coordinates, and spatial observation data from different sensors with different spatial and temporal resolution, and socio-economic and cultural data, various physical significance. And some of this data are very small size, but most of them are very huge, like remote sensing image. One image could reach 1 gigabytes in data volume. So it's also not only requires the data sharing, but also has high requirements on the computing capacity. So here you can see this is diverse detect means for the research data accuracy for the geoscience research. We have so many sensors, and we have so many data to deal with to proceed. So This diagram shows data sharing, the rules of data sharing for the scientific research. We collect data from different resources. This is an example of satellite data, and we also input data from shared resource and produce the semantic data, and finally it was converted to the data products. So it's a circle from the data to information and knowledge. And also the other characteristic of scientific big data is high complexity. So most computation related to the scientific research is connected large complex non-linear system with highly complex data model. So it requires combination of complex system theory, estimation theory, and also disciplinary or cross-disciplinary to explore the data solution. So here is another example for the ecosystem and environmental studies. So as you see, this all the data can be used for this kind of research. So this is an example of global meteorology observation. Data networks, which includes the GeoNetcast, which is developed by the United States, and the IMUScast from the European Union, and the CMEcast from China. Almost, you can see this system almost cover all the continents and ocean area with the influence land weather system. Next slide. Science mostly is conducting large complexity system with a complex data model. So it will cause highly uncertainty. This diagram shows this is kind of uncertainty because of the approximate model and no artificial system in data application. Also, scientific data from different sources may exist errors and incompleteness, leading to a high degree of uncertainty for the research. So there are also some innovation issue and governance issue when we promote scientific big data and research. Something about the data model and storage is about data integration, distributed storage, data modeling, and dynamic query. And also we need to research some technology on intelligent analysis of complex data, which means analysis of massive data and comprehensive data analysis. Also for capacity on computing is parallel computing and processing. It arose some governance issue about data quality because data from different resources, normally from different scientists. So if we want to promote the data sharing over the network, there must be a unified framework, probably a standard to accelerate this kind of data sharing. Also, it's difficult to validate the data from different sources. So there must be some validate method and principle for the data validation and calibration. Some issue about big data security, and also because different data scientists are doing their own work, so the scientific result normally belong to the personal research. So it's the intellectual property protection also issue we need to think about. So, in my conclusion, to big data for scientific research, it requires not only advancement on innovative technology, like data modeling, storage, but also on the data sharing and governance issues. So in big data age, scientists have strong design for access to open data. As we know, National Institute of Health, that is of United States, NIH, already issued the data sharing policy for all the genomic data, and all the projects funded by the NIH will providing the data set during their project. So it's a very great step for the data sharing. For earth science, there will be more and more data shared for the scientific purpose. And obviously, network will play more important roles in future. So in cyberspace, almost all the area, more openness means less obstacles and more beneficial to the leader in high technology. So network helps the technology advancement for multidisciplinary. It's not only on data sharing, but also modeling sharing. I have news here. In the implementation plan for the future 10 years global Earth observation system, the model web was proposed in the GEO destination 2025. So by analysis this important issue for research big data, we hope Internet would expand, acknowledge, and reduce technology gap between countries, and also promote balanced development, benefit human beings with science advance. Okay, that's reference links of my presentation. And okay, thanks.
Thank you, Mr. Zhou Qiang. He very clearly to explain what is the differences of the big data in science research area from internet area. I think it's more complex, yeah? It's more requirements, more diversity requirements, different from different disciplines, sectors of science. And also here give us a very good ideas from application in remote sense areas. So I think your presentation is very useful for us to considering of the policy design. Thank you again, Mr. Zhou Qiang. Now I would like to invite the next speaker, Professor Svetlana from Russia. Yes. He is the Dean of the Faculty of the Business Informatics, National Research University, Higher School of Economics, Russia. Her topic is big data and new opportunities for education and business. Please, you have floor.
Thank you very much. First of all, I want to thank for invitation to participate in this very interesting discussion. I try maybe, first of all, to build some bridge between big data age and open data. Because when I prepared my presentation, I thought about those two paradigms. And I think that in big data age, open data becomes big. They have the same features: volume, velocity, variety, variability. And I must say that only one feature is critical for the difference between those two paradigms. This is veracity. Because when we talk about open data, we think that those data are approved data. So people or organizations who will use those data may use those data and don't think about their veracity. But in big data age, we must understand that open data will include not only information, not only data, but also knowledge, I think. Also knowledge, also the results of big data analytics. And we must think, in this case, about confidence in analytical methods. We must think about the source of this data, and we must think about the results. So I think those two paradigms useful to each other. Maybe big data services will be more correct if we will think that those services will produce data, information, knowledge for open space, for open information. It's previous part of my presentation. And then I want to start maybe discuss the big data implementation in different aspects. When we think about this implementation, we must take into account several important aspects. First of all, it's special features, special characteristics of area of economics of social areas. Second aspect is environment, and then, of course, maturity phase of technology. Because today, of course, many organizations, many people tell that they use big data analytics, but what is the level of this analytics? What is the tasks, the problems for which analytics is used? And of course, about expected effects. First of all, I want to consider maybe business applications, because I'm a dean of business informatics department, and our department works with many Russian companies as companies in IT, not only Russian, but such famous companies as IBM, Microsoft, EMC, and we first of all think about applications of big data. First of all, I will look at business applications. It's two very interesting parts of discussing the difference between two paradigms, because big data in business may not be open data. It may be data in the results that is not available to each. For maybe such a short survey, I take very interesting research from the side of such companies Tableau, and I must say that Tableau in Gartner Magic Quadrant is the highest company in big data analytics today. And this is the result of survey of companies from different sectors of economics. And you can see on this slide, I must think you all can see it good, that there was one question, in which sphere and how important for you to use big data analytics instruments. And we can see that more important parts of enterprise activities is strategic decision making, finance and accounting, marketing and communications. And I must say that in Russian sectors we do such investigation. And we saw that, of course, marketing and finance, first of all, risk analytics for finance sector is very important and really existing sectors of big data analytics in Russia. Sorry? Then if we look to the social sphere, first of all, I want to emphasize such spheres as health, education, services, housing, and of course, big data has now a significant influence on the sphere of science and culture, and just now we heard very impressive presentation about its influence on science. But I must say that despite the interests in technology, really not a lot of companies are able to use it in practice. And also we try to use Klein research to the understanding of this phenomena. And if we will look at big data as an innovation, and this is innovation. It's innovation for each enterprise, for each sphere, because this innovation demands new organizational structure, it demands financing, and so it's innovation. And you can see that only big companies with well-developed infrastructure, not only IT infrastructure, but infrastructure, maybe environment in human resources, can implement it. It's also important to note that company may be on the different level of maturity of the technology. To show this, I used a very interesting paper and chart of Bill Schmarzer, and he shows that there are 5 levels, and I must say that now different companies, different spheres are on the different levels of this chart. But of course, as professor, and I'm professor of Higher School of Economics, of course, for me, maybe the most interesting sphere of big data and open data is education. So maybe I tell more about big data in education processes. I must say that education process involves the creation and processing of large amount of heterogeneous data. Coming big data technology drive new changes in education. They become maybe a locomotive for developing new approaches to education process, mostly due to new analytical tools. On this slide you see that maybe today, first of all, in educational organization we can see academic analytics. This analytics based first of all on some indicators, and there is a gap between those indicators and really learning process. It's very important for educational organization to make a bridge between data of learning process and academic analytics, because then we can see real analytics of educational organization. And big data give us that opportunities. What may be more interesting opportunities for learning analytics? Unfortunately, it's maybe not easy to read the text on this slide, so maybe I can say you that this is improvement of classroom experience through personalization, identification, at-risk learners, self and peer grading, predicting student performance, smart curriculum, discourse analysis, estimation openness, and so on. And of course, improving of attractiveness of education services through consulting and advisory services in choice of postgraduate education and work patterns and success or failure. What is critical for implementing this all these opportunities to the existing education system? First of all, that's proper data collecting procedures and tools. I must say that in this part there is many problems, not only technical problems. Maybe they are not the most important problems. The most important problems is the problems of human rights, because maybe some of students or some of lecturers is not ready for collecting the data about their behavior. Next, so this is, I think, very interesting part, very interesting topic for different aspects, for different investigations. Of course, education must have big data skills, and those big data skills must have not only lecturers, professors, but students too. And it's a problem to make students and professors, teachers, to make them data scientists in some area, in educational area. Of course, I said that we must build a bridge between learning analytics, learning processes, and academic processes, academic analytics. So we need new metrics of quality of the educational process and the educational institutions. And of course, we need integration of big data analytics with modeling tools, the models of learners, teachers, and all education processes. We must have those models because we need feedback and feedback is critical for realizing new educational paradigms based on data-driven processes, data-driven education. I must emphasize the critical areas. Critical areas that we must take into account and that maybe need not only maybe need not decisions, but first of all maybe need some philosophy of those decisions. Of course, it's transformation of information management, traditional information management. Maybe it must be information government, and maybe not only information government, but knowledge government. I think we need new models, we need new rules, we need new ideas for that. And of course, we need so-called big data culture. Big data culture may be very important thing, because these tools, the tools of big data paradigms, can transform information space into a space of knowledge. And those knowledge will be open in open data paradigm, in using open data paradigms. This can be both a source of more correct decisions, new decisions, very good decisions, and at the same time, it may be a source of false decisions, if we will get not correct knowledge. And I think that special role here belongs to the representatives of science, culture, and education. Thank you very much.
Thank you, Professor Svetlana, for your presentation. It's very clearly to make some analysis of the big data application in the social and economic areas, and particularly in business and education areas. So I think it's a very interesting presentation. Thank you very much. Now I would like to invite the last speaker, our last speaker, Professor Liu Chuang. Her topic is core data, WSIS plus 10, on public funded data sharing for science and sustainability in developing countries. I think Professor Liu Chuang, she's an expert in the core data platform. A lot of activities he was involved in, and I think her presentation would be very useful for us. Please, Liu.
Thank you, Mr. Gao. Today we talk about the data. So before the data, there is a code, the code data. So there are two meanings. One is this is an international organization, and there are 46 years old. Another one is data in the big data area. So we need a cooperation, coordination together. So we give a little bit more time to the core data. But this year is a very special year. Now this is 10 years between the visas. The visas phase 1 is 2003 in Geneva. And the visas phase 2 is Tunis in 2005. So this year that's between them. That's between very, very important. And next year, I think yeah, for the IGF is very important. The 10 years old, and also is for the VCS phase 2 is 10 years also. So I would like to have a summary, and then from the experience what we already done, so we can understand how dealing with the open data and the data publishing. So you can see this in 2003 in Geneva. There are 2 very important documentations published. One of them is Geneva Declaration. In this Geneva Declaration, there is a very important sentence, is science has a central role in the development of the information society. And in the second phase, in Tunis phase, so CODATA, and on behalf of the ICSU, International Council for Sciences, gave the promise and have the action agenda. This 3 minutes in the speech, the Professor Iwata, he was the president of CODATA, gave only 3 minutes in the plenary. So the promise, CODATA will try hard to help in the open data sharing, and also reduce the digital divide. And after then, so what is our actions? We have 7 action lines. What is our actions? First of all, we have a focus. We have 2 focuses. One is public funded research data sharing for benefit of society all. So there are so many data. There are private data, joint venture data, and the different kinds. But we, scientific communities, focus on the public funded data. How dealing with this kind of data? How make this kind of data benefit all society? This is one of focus. Second one is bridging the digital divide from the efforts of international, national, and the case levels. So how to do this? So we have several action lines. Action line 1, we have team, establishment of the CODATA task group team. So this task group just before the visits. So it's established in 2002. That's the focus, that's for the visits actually. And each 2 years get a review, peer review, to evaluate whether this task group is good or not, whether it's valuable to exit or to keep going. So we passed each 2 years, passed the exam. So 2004, 6, 8, 10, 12, and this year we have another evaluation. We are very confident we will pass this. And then we have the teams. We have the co-chairs from China, from US, Germany, Kenya, so different term. They are not 10 years. And then we have the members from 17 countries. Some are from them from industry country, but most of them are working in the developed countries. And then what we are working together. Another is we collaborate with the worldwide stakeholders. We call, because for developing countries, we have the common difficulties, so we need money. We need support. We need everything, almost most of the things in the industry country, we have empathy almost. So there we called stakeholders in the worldwide. So we work with China, US, Germany, and other countries, not only, but the international organizations, Asia Pacific Network for Global Environment Change, International Panel for International Academy of Panels, ICSU, GEO, World Data Systems, OECD, UNDESA, UNESCO, and whatever who are interested in these issues, we work together. And the line 3, action line 3. we participate the visits and the follow-up activities. So in the 2003, we participated too. In the March, we had in the UNESCO in the Paris, we participated in the pre-workshop, and then we were in Geneva. And also in Tunis, so the same thing. We have a pre-workshop and then in Tunis. Not only we participate in each follow-up actions. After the visits and the UN initiated, there are two programs. One is IGF. Each year have one forum. Another one is UN Gate. This is a global alliance for ICT and development. But this program is closed in the 2010. But we participate in each of them. So this one, you can see someone, you can see this about Moscow and Anna, and also Josia, and we have a remote commander here. So we work together. Each year, we participate in IGF. We identify what the issues. We need to work together, identify what the challenges, and how to dealing with the challenges. What is our opportunities? How we can solve all these difficulties, and then what could be our productive. So we discussed a lot about the principles, guidelines, best practices, and the cases, and so on, all related. We one by one. Each year we follow this. We keep going, keep talking, keep make a voice to the UN. Say, this is our voice. Please pay more attention to ours. Then another actions, we have a country series, a regional series, international workshops, focus on the challenges and what the needs from the countries and the regions, on data sharing, strategies, and the policies. We have this, several workshops in China, Beijing, Shanghai, in the South African, Pretoria, and Brazil, Latin American, and also Cuba, and Colombia last year, and this year in Kenya also. So we have a country series and to focus on what developing country needs about the data, open data. And not only, we also work together with the UN DESA. So this is the e-science, we call the e-science, and the e-government. So how about the government data open, and how the research data open? So how we can work together? So this, I think, is Dennis here. I think Dennis here from UN DESA, and I'm very glad he's here. And I think we work together. Another action is capacity building through training programs. We have 1 month training programs each 2 years in China. And at the end, we have 2 days to 7 days short training workshops. This we mostly training trainers together. And in Mongolia, Colombia, Kenya, China, and several places. Also, we have 1 to 3 years university degree training programs for developing countries in China, in university. And also 3 to 6 months exchange scholars program. All this is for help developing countries so we can reduce the digital divide from the capacity building, like developing countries grow up gradually. And this is, we just have this training program the last month in Jakarta, in the Kenyatta University of Agriculture and Technology in Kenya. So the Minister of Kenya in the Information and Technology gave very high comments, and then they promised to launch the national program and to establish a data center in Jakarta, in Kenya. So this is very, very good news. Another action lines, we have cases and best practices. I just list, because of time, I just list several the cases and best practices. One is the progress of the national science data sharing strategy and policy changed in China. And also not only policy and strategy, but infrastructure progress. Another one is Mongolia and Kenya. And participants formally to join the CODATA as a national member. So they can get the knowledge from the international organizations. Another one is South Africa, established a World Data Center on public health and environment for providing data sharing services, and it is supported by the IGF. And another case is Kenya Jakarta, established a data center for services not only Kenya, but the East Africa. One of the best practice, so we have the support, not only the strategy, policy, but we have actions to support, for example, Haiti earthquake, very quick to response to the UN. We have the 1 meter resolution road system, and collect the camps, and so on. And in the end, we got the very good comments from UN letter. So this is really, the UN need that. And another case, another best practice is the open knowledge environment. We have a digital Linchajiao Museum. This is a joint effort of International Geographical Union, CODATA, and the Geographical Society of China. So this is a joint effort, and it's fully open available. So this is we collect all this worldwide stamps related to geography and regional and environment, and then we say that this is linked to the curation with the knowledge and set up this. And this is really is inclusive mechanism on open knowledge environment. And the contributors, there are more than 200 contributors worldwide, including Nobel Prize winner, and also President of Indian Academy of Sciences, and many professors, and even kids, students, will contribute to this. This is fully practice on the Geneva Declaration, inclusive, and everybody and free to join and share this. Another best practice is global change research data publishing and repository. This is the most of the data. When we talk about the data in a big data issue in June this year in Beijing, and then scientists they said everybody want to share somebody else's data. Very few people want to put their own data online to share it with others. So this is why. So we need to find the key where the problem is, because they are not recognized, not rewarded. Because why scientists they publish their papers very active. However, publish their data is go home. So this is the problem. So we need to find the key, and then the solve this is data publishing, peer review data publishing, and not only publish data, but publish the data related information. So peer review the data and the data paper and the metadata also. So this is the platform. We work not only for the China. This is operated by my institute, Institute of Geography of Chinese Academy of Sciences, and also some, for example, Jianquat is partly joined this. So this is a platform or a part of the infrastructure for developed countries to publish their data. So another line is the last part, very important, is last month we passed this the data sharing principles and the guidelines. We call this as a Nairobi data sharing principle and the guidelines. Participant in this workshop is CODATA World Fed, WFEO, Ministry of Information and Technology of the Kenya and UNESCO and so on. So these organizations and all agree we need to publish this and practice this Nairobi data sharing principles should freely, openly, informative, and safety sustainable. So this is what we already done. They are not 10 years. So we have several conclusions. One is this efficient coordination and cooperation on data is needed. So CODATA should continue to play the leading role in the world and with other stakeholders to reduce to enhancing the data sharing in developing countries. And also openness of public funded research data and information has a great benefit and will continue to do so for sciences and sustainability. And also openness of public funded research data should work together with the government data, publishment of government data together. So we also, in the next coming years, we should work together with the UN data. And also keeping the openness is one of the critical issues of IGF in the coming years is necessary. And it is one of the key issues for reaching the post-2015 Sustainable Development Goals. Thank you.
I think from Professor Liu's presentations, where all the recognized the core data is model of for open data principle, and also they are very follow the big data culture. Thank you very much for your presentations. Okay. Unfortunately, the time for our workshop ran out, but I still want to leave some time for audience. Raise your questions and make some comments. As well as I would like to remote participants, if there are some questions, please tell us. Now open floor for audience. Yeah, okay, please.
Louise Bennett, BCS UK. There are just 2 points I'd like to make very quickly. One is, I think in your definitions of open data, you've left out something very important, and that is that big data and open data sources nowadays are largely unstructured, and that requires a very different analytical techniques from old statistical data sets. To take the meteorological example, I'm a meteorologist. When I first started, I plotted the meteorology of each station as it came in each day and drew a map. Then we had satellite, and I was trying to forecast floods. Now I would use things like YouTube, which is completely unstructured. I don't know where it's going to come from. That requires very different analytical techniques, and I think it's very important to consider that. The other issue that was only vaguely touched by Anna in her presentation is some of the problems, and they're to do with the ethics of using big open data sources if they include personal data. And I would recommend to you a publication that's just come out in the UK between the Office of National Statistics and the Medical Research Council for how to do analysis of big open data sources of everyone's medical records for medical research, but reassuring the public that they will be properly protected and ethically scrutinized. And I think that's a vitally important thing in open data analysis that is using personal data.
I think, could you summarize your two questions briefly?
My questions would be, do you agree that a lot of open big data is unstructured and therefore requires new analytical techniques? And the second one is that if if the open data you're using includes personal data, you need to consider ethical issues. And I've suggested someone who's done a publication that I think might help you if you do agree with that.
I would like to ask Mr. Zhu Qiang, ask your first question. Then, Mr. Anna, you can answer second one. Okay. Yeah, first.
Well,
Mr. Zhu.
I can only say that I totally agree with the comments.
Yes. I add some quick comments. I totally agree with you because, as you know, taking the information with remote sensing is definitely is unstructured. Maybe to some extent is semi-constructed data. It requires very special technical on the data modeling, data processing, and especially even application, because it needs the inputs of the different data from different sources, like social, economic data. Otherwise, it will not play very important roles for decision maker and the public user. Okay, thank you.
Okay. Words do you want to say?
No, I already said that I totally agree with the comments made.
Okay. From remote participants, there are some questions or comments?
Sorry, Liu.
Oh,
To Professor Liu, it seems sharing that is a little bit difficult. What's the main problem? Thank you.
Yeah, the problem is the data contributor. They are not accredited or rewarded. This is the key. Why don't want to share their data? But if we want like a paper publications, scientific research paper publications, so we can partly and solve this problem. So now DOI is international standards. DOI is a help in the technical help. So I think that's and the money publishers will work on this. I think that's a great progress.
are there any other questions or comments? I see no. So I want to conclude our workshop, and I think this workshop was successful, and all the panelists make a very interesting and useful presentation for us, and raise the importance of the big data and open data concept. And also they raise a lot of advices to improve and encourage big data applications in different areas, including education and scientific research areas. And also they suggest should be consider differences from the internet application, big data, and also research and education fields. I think in education and education and research, scientific research areas, more complex. I agree with Mr. Zhu, the viewpoint. So I'd like to thank all the panelists for your contribution, and also thanks for all the participants here and the remote participants joined us. Thank you very much. Now I announce the workshop conclude. Thank you very much.
Thank you.
Thank you.